Hello everyone, welcome to the fifth tutorial of topic 3, Formulae, stoichiometry and the mole concept. So uh, actually last class we had discussed the basic concepts of mole and what it means to use the term mole and all that. So today I'll be showing you an easier approach, an approach that I find handier and easier to solving the problems and doing the calculations related to this mole concept. So last class we had seen that 1 mole of sodium or 1 mole of any substance will have a mass equivalent to its, you guessed right, you guessed it, the atomic number. So basically 1 mole sodium will be having a mass of 23 grams, and 1 mole calcium, which has an AR of 40, will have a mass of 40 grams. 1 mole of say oxygen, which has an AR of 16, will be having a mass of 16 grams, and so on. So so that's all good, but there's a more systemic approach. There's a more easier. There's a more theoretical approach to it. These calculations, and it is determined by the formula mole equals mass by your MR or AR, depending on depending on what you're provided with. If it's a molecule you're provided with, you'll be using an MR. If it's an element you're provided with, you'll be using its AR. Or yeah. So there something I missed last class. That is, the unit of mole is known as MOL, right? So, for instance, 23 grams sodium has 1 mole of sodium in it. We write it this way, right? So whatever mole you calculate, you'll be using the unit mole, MOL, right? So the unit of mole is, well, though it sounds the same, but it's mole, right? The unit of mole is mole. All right. So there are a couple of things I miss. There are a couple of things I need to add to the mole concept to make it a bit more easier for you guys to complete your syllabus. Their lessons are as follows. Well, the first thing what we need to understand, what we need to think about is we've known that 1 mole of any substance will have a mass equivalent to its AR or MR, right? But the question the question that still lingers is, how much is that? Like, yeah, it's pretty understandable that 23 grams of sodium will be having a mass, an amount of 1 mole of sodium in it. Will be having 1 mole of sodium in it. That's pretty alright, but how much exactly is that? How many atoms or how many particles of sodium will be in it, right? For instance, right, you're being provided with X gram of a substance, right? X grams of a substance, right? So, suppose it means having Y mole of that substance, but that's all fine. But the question that still lingers in our minds is, how much is it? How much does it exactly look like? So, to give you a clearer idea or a clearer understanding of what this means, we have another relation relevant to the mole, which is 1 mole of any substance. 1 mole of any substance will be having 6.02 into 10 to the power 23 particles of that of the related substance. Like, for instance, 1 mole of sodium will be having 6.02 into 10 to the power 23 atoms of sodium. 1 mole calcium carbonate 1 mole calcium carbonate will be having 6.02 in 10 to the power 23 particles of calcium carbonate. 1 mole ethanol, C2H5OH, will be having a similar amount, aka 6.02 into 10 to the power 23 molecules of ethanol, right? So basically what I'm trying to imply is 1 mole of any substance will be having an amount of 6.02 into 10 to the power 23 number of particles in it. Now, if you've got an element, it'll be 6.02 into the power 23 atoms. If you've got a compound, or if you've got a molecule, if you've got a covalent compound, it'll be 6.02 into 10 to the power 23 molecules of that covalent compound, right? And so on and so on. So basically 1 mole of any substance has 6.02 10 to the power 23 particles in it. 1 mole of sodium has 6.02 10 to the power 23 atoms in it. 1 mole ethanol has 6.02 10 to the power 23 molecules of ethanol in it, right? Means this is a molecule. So 6.02 10 to the power 23, there are 6.02 in 10 to the power 23 this molecule is present. 6.02 in 10 to the power 23 of them are present in 1 mole of ethanol. 1 mole of sodium, this is a sodium atom, so 6.02 in 10 to the power 23 of this is present in 1 mole of sodium. This is calcium carbonate. 1 mole of calcium carbonate contains 6.02 in 10 to the power 23 of these, right? So I guess that's that. And there's another relation we are supposed to know. By the way, this number is known as the Avogadro constant, right? The Avogadro constant. All right. So there's another relation I think we need to know, which is this is 1 mole of any substance, right? 1 mole of any substance, solid, regardless of its state, right? There's another relation that is 1 mole of gas, any gas, will be occupying a volume of 24 dm cube. Like 1 mole carbon dioxide will be having a volume of 24 dm cube. 1 mole of hydrogen will be having a volume of 24 dm cube. 1 mole of hydrogen chloride will be having a volume of 24 dm cube, and so on. 1 mole of any gas will be having a volume of 24 dm cube of that particular gas, right? So any gas in 1 mole will be occupying a space of 24 dm cube, a volume of 24 dm cube. Just to note, dm cube, 24 dm cube also means 24,000 cm cube. So in your questions, your data might be set in dm cube, or it might also be set in cm cube. So you might need to switch between the units. So I just showed you the conversion rate. 1 dm cube equals 1,000 cm cube, so 24 dm cube will be equal to 24,000 cm cube. So 1 mole of any gas will be occupying a space or volume of 24 dm cube or 24,000 cm cube. I guess that's pretty clear. That's clear. All right, let's move on. Let's move on to a couple of basics, right? So for instance, alright, so sodium plus hydrochloric acid will be forming sodium chloride and hydrogen. So in case of as we said earlier, in case of when it comes to balancing equations, we need to balance both our right hand sides and left hand sides of the equation given. So basically there are 2 here, so we need to have a 2 here, or we can 2 here, and then we can balance a 2Cl. So in order to make this 2, we need to have a 2 here, and 2 Na, we need to have a 2 Na. Or you could have just simply given a half here, just to make this 1. You needn't change the entire thing, right? You could have just done this as well. All right, what I want to say now is what I want to speak now about. Alright, so what I wanted to speak, what I want to tell you now is, for instance, so let's consider the concept of ratios, right? In this equation, according to this balanced equation, 1 mole of sodium reacts with 1 mole of hydrochloric acid. Alright, state symbols are a must, right? For any equation you write, please include your state symbols. Aqueous, and this is a gas. So for instance, so let's look deeper into the equation. So 1 mole of sodium will react with 1 mole of hydrochloric acid to form 1 mole of sodium chloride and half mole of hydrogen gas, right? Right. So for instance, you're provided with 3 mole of sodium, and you're asked to find the number of moles of hydrogen gas that will be produced from this reaction, right? So let's just see. Initially we had 1 mole of sodium, right? And 1 mole of sodium produced ended up producing half mole hydrogen gas, right? So if 1 mole sodium produces half mole hydrogen gas, 3 mole sodium will be producing, you guessed it, 3 into half mole hydrogen gas, which is 1.5 mole hydrogen gas, or 3/2 moles hydrogen gas, right? So yeah, that was one. And then for instance, you're asked how many moles of hydrochloric acid are needed to react with 3 mole of sodium. In that case, since 1 mole hydrochloric acid reacts with 1 mole sodium, my bad, sorry. Since 1 mole hydrochloric acid reacts with 1 mole sodium, so 3 mole sodium will need 3 mole hydrochloric acid to have a complete reaction, right? Yeah. So yeah, basically, so far we've covered how we've covered the details of deductions related to mole calculations. Oh, so there's another example I ought to mention. Suppose you're asked, you're given the question that you've been provided with 4 mole of sodium, or let's not go to 4 mole, you've been provided with, say, 46 gram sodium. Now which was reacted with an excess of acid. I will, point to be noted, I will be coming back to the discussion about excess reactants and the limiting reactants, but that's all for later. Let's just consider this a simplified version of calculation. So for instance, you're being provided, you said that you're provided with 46 gram of sodium. Now the question that you've been asked is, what volume of hydrogen is obtained from 46 gram of sodium? What volume of hydrogen is obtained from 46 gram of sodium? So the first thing you need to do in these cases is just convert this to mole first. That's the basic rule of thumb for every molar calculations. For every molar calculation, you need to convert every non-mole unit to moles, right? So this converted to mole is 2 mole, right? Oh, let me show you how it's done. So it's just mole, using our formula, mole equals mass by mR. So the mass you've been provided with is 46 gram divided by mr, which is AR in this case. So sodium has an AR of 23. So basically the number of moles of sodium present in 46 gram is 2 moles. So you've basically been provided with 2 moles sodium. Now you've been asked how many or what volume of hydrogen gas is produced or evolved from 2 mole of sodium, right? For 46 gram, aka 2 mole sodium, right? Alright. So 1 mole sodium produces half mole hydrogen gas, right? So 2 mole sodium, 1 mole sodium produces half mole hydrogen gas. So 2 mole sodium will theoretically produce half into 2, aka 1 mole hydrogen gas. So you've just found that 2 mole sodium will produce 1 mole of hydrogen gas, but that's not what you've been asked. You've been asked the volume. So now you need to convert this mole to volume. So you need to convert 1 mole hydrogen gas to its volume. So we know, 1 mole of any gas under standard conditions occupies a volume of 24 dm cube or 24,000 cm cube. So we'll just write 24 dm cube, since 1 mole hydrogen gas will occupy a volume of 24 dm cube, right? So this is our answer. The questions might vary in terms of complexity, but this is the basic structure, right? All right. Now let's move on to the issue of limiting reactants and excess reactants. Oh, I shouldn't have erased all that. Just a moment. Yeah, so this is a balanced equation. What I want you guys to know is this is a balanced equation, and no force or nothing on earth can change this balanced equation. The ratio will always remain the same. The ratios will always remain the same. 1 sodium will always react with 1 HCl, 1 mole. 1 mole sodium will react with 1 mole HCl no matter what. 1 mole sodium will give rise to 1 mole sodium chloride no matter what. 1 mole sodium will give rise to half mole hydrogen no matter what. 1 mole HCl will give rise to 1 mole NaCl and half mole H2 no matter what. So nothing can change that, right? So this will remain universal. This equation will remain universal. Based on the balanced equation, you need to do calculations that we are about to do. So for instance, the question says that you've been given 69 gram of sodium with you've been given 69 gram of sodium with let's say 73 grams of HCl, right? So you've been given 69 grams of sodium and 73 grams of HCl. Now you're asked what volume of hydrogen gas will evolve or will be produced from this reaction. What volume of hydrogen gas will be evolved from this reaction, right? So the first thing you need to do is, as always, as I said, convert all non-molar units to moles, right? So 69 grams of sodium, convert this to moles. So when converted, it'll be like mole equals mass by mr. So the mass you've been given is 69 divided by AR of sodium, which is 23. It'll be 3 mole sodium. So you've been provided with 3 mole sodium, right? Now let's convert this 73 gram of HCl to its mole. So 73 mass by mr. So 73 by mr, which is 1 plus 35.5, which should be It should be 2. So 2 mole, right? You've been given 3 mole sodium and 2 mole HCl, or hydrochloric acid. Now, as we can see from the equation, 1 mole sodium will react with 1 mole HCl, right? So 3 mole sodium should theoretically react with 3 mole HCl, right? But have we been provided with 3 mole HCl? No, we've been given 2 moles, right? So we've been given with, but then again, so which reactant do we have that is lesser in amount than the one we need, than the amount we need? Which of these two reactants are less, which of these two reactants is less in amount than the one we needed? HCl, right? Hydrochloric acid, right? So the reactant which will be lesser than the amount we need is known as the limiting reactant. The limiting reactant. I'm not going to the full form, I just write LR. And the other reagent, or the other reactant which will be in excess, which will remain in excess, is known as the excess reactant. Now the thing is, the reaction, or the amount of products produced will always depend on the amount of your limiting reactant, right? Now, so basically what I want to say is the amount of NaCl produced, or the volume of hydrogen produced, will depend on the limiting reactant, which in this case is hydrochloric acid, right? And the question is, why does this happen? Understand that you need HCl to react with sodium, the same way you need sodium to react with HCl. But when 2 mole sodium will react, you need 2 mole HCl for that, right? So 2 mole HCl will react with 2 mole sodium according to this our equation, right? So after 2 mole HCl has reacted, it's all used up, right? There's no more HCl there's no more HCl left, right? So basically, after 2 mole HCl reacts with 2 mole sodium, there's no HCl left, but there's still 1 mole sodium left, which means sodium is in excess. And the HCl has all been used up, right? All of the HCl has been used up. So understand that when a certain reactant is all used up, it can no longer play a part in producing the products. And the products cannot be formed without HCl. No NaCl or no hydrogen gas can be produced without HCl. So after 2 mole HCl has reacted with 2 mole sodium, the reaction stops, right? Yeah. But sodium still remains, right? Yeah. So basically, that's the reason why the reaction depends on the limiting reactant. So this is the reason why limiting reactants play a very big role, a very big part in the production of in the production of your products, right? So So basically, the question that we had was, you've been provided with 3 moles, no, actually 69 gram and 73 grams of sodium and hydrochloric acid respectively. Now you need to calculate the volume of hydrogen gas produced, right? So using our formula, we deduced that you had been provided with 3 moles and 2 moles of sodium and hydrochloric acid respectively, and we successfully identified or located the limiting reactant, in this case hydrochloric acid. And as we said, the amount of product produced will depend on the limiting reactant, in this case hydrochloric acid. So the volume of hydrogen, the amount of hydrogen produced will depend on the amount of hydrochloric acid. So the amount of sodium will not come into play, since this is not the limiting reactant. Hydrochloric acid is. So we have 2 mole hydrochloric acid with us. So 1 mole hydrochloric acid theoretically produces half mole hydrogen gas. So 2 mole hydrochloric acid should produce 2 into half mole of hydrogen gas, which is 1 mole of hydrogen gas. But you've been asked to calculate the volume of hydrogen produced, right? Right? So basically, you've been asked to calculate the volume of hydrogen gas produced, right? So far you've found the number of moles of hydrogen gas produced, but not the volume. So now you need to convert this mole to the volume of hydrogen gas produced. So the technique we used before, as 1 mole of any gas occupies a volume of 24 dm cube, and since hydrogen has been produced, just 1 mole of hydrogen gas has been produced, so 1 mole hydrogen gas will take up a volume of 24 dm cube likewise. So this is our answer once again, that from 3 mole sodium and 2 mole hydrochloric acid we can obtain a maximum of 24 dm cube of hydrogen gas. I hope that's clear. That's pretty easy. So this is where the question of limiting reactants and excess reactants come in. So the amount of product produced, the same goes for sodium chloride, to be honest. If you'd been asked, you might be asked, the question might be as such: what mass of sodium chloride will be obtained or will be produced from 2 moles from 73 gram of HCl and 69 gram of sodium. Let me repeat the question: what mass of sodium chloride can be obtained from 73 gram of HCl and 69 gram of sodium? So similarly, convert the mass of both reactants to moles, and then identify the limiting reactant, and then based on that find the number of moles of sodium chloride that will be produced. So in this case, since hydrochloric acid is again the limiting reagent, so on hydrochloric acid everything will depend, right? Everything will be depending on hydrochloric acid. So we have 2 moles of hydrochloric acid, and since theoretically 1 mole of hydrochloric acid produces 1 mole sodium chloride, so 2 mole hydrochloric acid will produce 2 mole sodium chloride. Now we haven't been asked to find the number of moles of sodium chloride produced. We've been asked to calculate the mass of sodium chloride produced. So we have our mole of sodium chloride, and we also have the MR of sodium chloride, which can be calculated easily. So from our formula, we have mole equals mass by MR equals mass by MR or AR. So here we've been asked to find the mass, right? So finding the mass is pretty easy. Just multiply the number of moles by MR and you'll be getting your mass obtained. So the number of moles you have is 2 here, and the MR of sodium chloride can be found easily by adding both ARs up, which is sodium has an AR of 23 and chlorine has an AR of 35.5, right? Just add the two up and you'll be getting the MR of sodium chloride, right? So 23 plus 35.5 is 58.5. So just multiply 58.5 by 2 and you'll be getting your mass. So since mass equals mole into MR, we have our mole as 2, we have our MR as 58.5. Now just multiply by 2, you'll be getting 117 grams of sodium chloride. So this is your answer. 117 grams of sodium chloride will be produced from 73 grams hydrochloric acid and 69 gram of sodium. So this is how you find the amount of product produced using the concept of limiting and excess reagents. Let's have a look at our syllabus. So far we've completed calculate stoichiometry reacting masses and all that. We've studied calculate stoichiometry reacting masses. We did use Avogadro's law in calculations involving gas volume. 1 mole of gas occupies 24 dm at room temperature and pressure. Yeah, we did. Oh, by the way, this is known as Avogadro's law. That thingy about 1 mole of any gas having a volume of 24 dm cube. Calculations involving the idea of limiting reactants may be set. So we've done question on the gas laws, and calculations of gaseous volumes, different temperatures and pressures will not be set. So we've completely done. We are done with our we are done with this clause. Now let's move on to the next outcome, which is apply the concept of solution concentration to process the results of volumetric experiments and to solve simple problems. Appropriate guidance will be provided when familiar reactions are involved. Alright, so yeah, this is important. This is important. And these need to be erased. All right, so there's another term you need to be familiar with. You need to familiar yourself with. It's known as concentration. Don't make me spell it again. It's terribly long, and terribly irritating. So concentration. So by concentration is pretty simple. It's just like the amount of substance you're having per unit volume, right? So here as well, so here the amount may vary, like the amount may be in moles, mole per mole divided by volume. I'm just writing the short form. Or it may be mass divided by volume, right? So that's pretty simple, and volume is calculated usually in dm cube, or you might also have cm cube here as well, right, as your volume. So that's pretty simple. And now let me show you an example of let me just show you an example of a neutralization reaction, which is basically the reaction of an acid and an alkali, reaction between an acid and an alkali. Sodium hydroxide is an infamous alkali, as a matter of fact. Sodium hydroxide plus hydrochloric acid to form sodium chloride and water. So there's no need to balance it since it's already balanced. As you see, we have 1 sodium here, 1 sodium here, 1 chlorine here, 1 chlorine here, 1 oxygen here, 1 oxygen here, 2 hydrogens here, and 2 hydrogens here. So the reaction is balanced, right? The equation is balanced. Now, suppose you've been provided with, but all are aqueous. All of them are aqueous, except for water, of course, which is liquid itself, right? Now, suppose you have been supplied with 0.0, right? 0.125 mole per dm cube. The unit is mole per dm cube, obviously. You've been supplied with 1.4 mole per dm cube hydrochloric acid. Now, what you've been asked is, the question is, how many moles or how much sodium hydroxide or what mass of sodium hydroxide will be required to neutralize 0.125 mole per dm cube hydrochloric acid, right? So let me go through the question once again. How much or no, what mass of sodium hydroxide will be required to neutralize 0.125 mole per dm cube of hydrochloric acid? The question is incomplete, right? Because there's another part to it. You'll be asked how or what mass of sodium hydroxide will be required to react with say 2 dm cube of 0.125 mole per dm cube hydrochloric acid. So let me write that here just in case, just to highlight it. So your question is, what mass of sodium hydroxide will be needed to react with 2 dm cube of 0.125 mole per dm cube hydrochloric acid. So this data is relevant, is related to your acid, right? So basically they say 2 dm cube of 0.125 mole per dm cube hydrochloric acid, right? So from here, as I said several times before, any non-molar units must be converted to units before beginning any calculation whatsoever. So here 1 dm cube equals 0.125 moles of hydrochloric acid. So 2 dm cube will house 2 into 0.125 mole of hydrochloric acid, which is 0.25 mole of hydrochloric acid. So 0.25 mole of HCl, right? Right. Now, from our reaction, we see 1 mole hydrochloric acid reacts with 1 mole sodium hydroxide. That is, 1 mole sodium hydroxide is needed to neutralize 1 mole hydrochloric acid. So, neutralize 0.25 mole of hydrochloric acid, you will also need 0.25 mole NaOH, since the molar ratio is 1:1, right? So 0.25 mole of sodium hydroxide, and then you have the mole of sodium hydroxide, right? So you need to calculate the mass of sodium hydroxide that is required. So it's pretty simple. You can always calculate the MR of sodium hydroxide and just multiply it with the MR to get your answer. So since mass equals mole into MR, derived from mole equals mass by MR, right? So multiplied by MR of sodium hydroxide is 23, plus oxygen has an AR of 16, plus hydrogen has an AR of 1, right? 23 plus 17 is 40. So 0.25 in multiplied by 40 into 40 is basically 10. No, it's basically 10, I guess. 40 into 0.25, it's 10. So your answer is 10 grams of sodium hydroxide is needed to react with 2 dm cube of 0.125 mole per dm cube hydrochloric acid, right? So one last thing I would like to mention here is the unit might change to gram as well. So in case you're provided with with a question that gives you its concentration in grams, don't freak out. Just calculate the amount of the mass of the reactant that you've been asked to find. Just multiply it with the volume, and then convert it to mole or whatever, and then do your proceed with your calculations. Right? There's no need to be. There's no reason to freak out. So yeah, that's that. So we just covered our second last learning concept as well. So now the last concept, that is calculating percentage yield and purity, right? So we'll cover this in the next class. Hopefully the last tutorial. The next tutorial will hopefully be our last. So thank you for bearing with me so far.